Students, now we'll see the next problem. Find the radius of curvature of the curve xy equal to c square at the point c comma c. Following the previous problem, by using the radius of curvature formula to find the radius of curvature on the given curve xy equal to c square at the point c comma c. Here given, what is given? Xy equal to c square at the point c comma c. At c comma c. First, we have to find y1, then y2, dy by dx, d square y by dx square, and then substituting the radius of curvature formula. Okay. Here xy equal to c square. Given problem is xy equal to c square. First, you have to find y equal to. Easily to find dy by dx, then derive from y equal to. Okay, here y equal to c square by x. Next, we have to easily find dy by dx. dy by dx. Or y1 dy by dx by e1. Okay, dy by dx differentiate with respect to x. So having denominator x, c square divided by x. C square is a constant. 1 by x. 1 by x differentiate with respect to x minus 1 by x square. How do you find the differentiate with respect to x in denominator? Here 1 by x is an here 1 by x. What is the differentiation with respect to x? Here d by dx of 1 by x. First, you have to write this can be written as x power minus 1. X power minus 1. As usual, differentiation formula. You know the formula? D by dx of x power n equal to n into x power n minus 1. The differentiation formula. Here n into x power n minus 1. Here x inverse. Having x inverse. Now differentiation with respect to x. Here minus 1 x power minus 1 minus 2. Okay. Bring to the power in front of the x term. Here reduce the power. 1 power. Okay, here minus 1 x power minus 1 minus 1. Here minus 1 x power minus 2. Here minus here x power minus 2 and as 1 by x square. Here minus 1 by x square. Differentiate with respect to x of 1 by x minus 1 by x square. Here c square into minus 1 by x square. Here dy by dx equal to minus c square by x square. Simply written minus c square by x square. Now substitute the formula dy by dx at the given point c comma c. X and y 2 points given c comma c. Now substitute here x point. Here minus c square by c square. Cancel the c square. Then minus 1. Here y1 equal to minus 1. Commit the value y1 equal to minus 1. Now, how to find y2? y2 means d square y by dx square. Then y2 equal to d square y by dx square. Now again differentiate with respect to x. Here already we know that dy by dx. Now again differentiate with respect to x. Here d square y by dx square means now differentiate with respect to x. Here minus x square is a constant. Here 1 by x square differentiate with respect to x 2 by x cube. Listen. Here 1 by x square. Here d by dx of then d by dx of 1 by x square. This can be written as x power minus 2. Now differentiate with respect to x by following the previous differentiation. Here 1 by x square here. X inverse. Here 1 by x and it is x inverse and then differentiate with respect to x we get minus 7 x square. We are following this formula. Here x power minus 2. What is the differentiation? Minus 2 x power minus 2 minus 1. Here minus 2 into x power minus 3. Here minus 2 1 x power minus 3 can be written as 1 by x cube. Here minus 2 by x cube. Now substitute here minus 2 by x cube. Here already having 1 minus take plus. Then d squared 1 by dx squared equal to c squared equal to 2 by x cube. Now substitute the point d square y by dx square. At the point is c comma c. Now substitute x equal to c. Yes, c square into 2 by c cube. Cancelling this c square, get 2 c cube c square, get 2 by c. Get y2 equal to 2 by c. Get y2 equal to 2 by c. Now, you know the value for y1 and y2. Let's substitute the radius of curvature formula. Rho equal to 1 plus y1 square. What is the y1 square? The y1 value minus 1. Minus 1 the whole square 1. Whole power 3 by 2. Divided by y2, 2 by c. Now simplifying this, 2 power 3 by 2. 2 power 3 by 2 divided by 2 by c. Then this can be written as, okay, 2 power 3 by 2 can be written as 2 into root 2 divided by 2 by c. Bring to the numerator for the c. Yes, c 2 into root 2 divided by 2. The denominator 2 can be written as root 2 into root 2. Cancelling this, the final answer is c into root 2. This is the rho value. Now, rho equal to c into. This is the final answer. This is the radius of curvature.